In this video, I want to show you how to make protected routes with API Gateway. Specifically, I'm going to show you the Terraform code involved in doing this, but before I get into it, let me just give you a demonstration. So right here, this isn't running on API Gateway, which is pipsandpython.com-api-users. If I contact this, what we get is a message from the Lambda. So API Gateway forwards this request, or proxies it in AWS language, you could say, to the AWS Lambda. And we also have another route, though, that's protected with Cognito. And what we have here is it's a post route to API-users. And if I run this, what we get back is message unauthorized. And that is because this route is protected, and specifically what it requires is an authorization header with a valid JWT or JSON web tokens. And so the great thing about AWS is it makes it very easy to add authentication to your application with API Gateway and Cognito. So basically, and I'll show you in this diagram here, API Gateway handles authentication automatically using JWT tokens issued by Cognito. So your backend, so say like Lambda functions, which is what's running under the hood here, don't have to actually validate the tokens manually, and you can just focus on the actual business logic. So basically what I'm going to set up here and show you how it works is we have our client or app, which will send an HTTP request with an authorization HTTP header, and then what we'll have next to it is a JWT token. Then we have our API Gateway, which will check the route, which secured as API-users with a post HTTP method, but it looks for the JWT token in request headers authorization, and then it validates it with the Cognito Authorizer. And I'll also show you how easy it would be to set up third-party things like Google sign-in, things like that. But basically, it checks if the token is valid, and if it is invalid, it will return a 401. And of course, also if the JWT is missing too. But if the token is valid, the Lambda function receives the request, which is an AWS proxy, which basically means it gets the entire request, so everything involved. And then we can just focus on handling the business logic and then return a response. So let me get started on the Terraform code and setting this up, and I'll go through each one of these resources one by one, explaining what's going on. So the first thing we're doing here is we just create an API Gateway, specifically version 2, which allows you to use HTTP and WebSockets. And specifically, we are creating an HTTP protocol, so we're not doing anything with WebSockets. And if you're curious, API Gateway version 1 is used more so with REST APIs. So if you want to use REST APIs, use Amazon API Gateway version 1. The next thing we need to do is create something called a stage. And a stage basically represents a deployment environment for your API. It's basically, though, in simpler words, it's just a string appended to your API Gateway URL. So if your stage, for example, say the name we have here is, say, cheese, then whatever your domain is, so it'll be like domain, and then it'll be -cheese. And probably more one that makes sense to say it could be version 1. So you could have a snapshot at version 1, version 2, but that's what a stage is. And default right here is actually a special name, so $default, which is a default stage, and it basically just means nothing is appended. So it'll just be just the main route or whatever your domain is. And then also we set down here auto deploy to true, which ensures that the changes are automatically deployed, so as opposed to going in and manually deploying your API Gateway. And of course, setting auto deploy true is more so useful during development or when you want every update reflected immediately. But for production, you actually might prefer some more manual deployments to control releases. And here's where we get into the stuff specifically related to authorization. So to add authorization to API Gateway, we need to use something called an authorizer. An authorizer basically just handles JWT tokens. And once set up correctly, API Gateway can validate JWT tokens issued without you needing to write any code. So you literally don't have to write anything. All of this will be handled under the hood by API Gateway. And this right here is how we define an authorizer. So the authorizer type right here, it's required, and its values are either JWT, and I believe also you can use, I think it's request. And request is essentially just a Lambda-based authorizer, so you'd have your own custom auth essentially, whereas JWT is just the built-in managed JWT validator. So for example, JWT is issued by Cognito. Identity sources tells the API Gateway where to look for the token, which will be in this right here, header, and then the authorization header. And then we have audience and issuer under JWT configuration. And basically, audience and issuer validate that the JWT was issued by your Cognito user pool for the correct client. So we can see what I have as a Cognito user pool client, which is basically just the client interacts with the user pool. So we want to make sure that the client belongs to us. And the issuer is our Cognito user pool. So which basically means that JWT was issued from our Cognito pool. And note, this is where you would change if you were wanting to use a third-party service, say like Google. What you would do is you would just change the JWT configuration to match that audience and issuer. So it's pretty simple. So you would do something along the lines of, say, paste in this here, JWT configuration, where your audience is your Google client ID, apps, Google user consent, and then the issuer would be just the accounts.google.com issuer. But I'm of course going to leave this to just the default JWT. Next, we need to work on let's focus on integrations, which basically means integrating a Lambda, which basically means now we need to have something handle the requests coming through the API gateway. And we do this with an integration. So an integration is basically the backend endpoint or service that handles requests for a particular route. Specifically, this resource here, API Gateway version 2, defines how API Gateway forwards incoming requests to the backend, like a Lambda function, HTTP endpoint, or just another AWS service. So right here, this integration type AWS proxy forwards the entire request to the Lambda, including headers, path parameters, and JWT claims if the authorizer is enabled. And all this is basically just default but required stuff. Next, we have our AWS Lambda permission. So we must also grant API Gateway permission to invoke our Lambda. So it can't just do that right out of the box. We need to say the action is Lambda invoke. The function name is going to be our Lambda function. The principal, which is basically who is it, and that is API Gateway. And the source ARN or Amazon resource number is our API Gateway's Amazon resource number. So this allows our API Gateway to interact with our Lambda after it's been integrated. And here is where we define our routes. So these two resources here, we have our secure route and our unsecure route. And so what we can see here is our route key. So post to API-users is integrated with our AWS Lambda, and it has an authorizer. So this right here, these two lines here is what protects it with the Cognito JWT authorizer. And we can see how the unsecure route has no protection. And this is all it takes. So these two right here is why if we do a curl to post API, we get unauthorized. Of course, we would be authorized if we applied an authorization header with the correct JWT, but that comes from this here. And then on API-users, this one is just this route here. We call that we can contact the Lambda. I'm going to be making a video on building all of this from scratch, including also I might use React as a front end, something like that. So please subscribe if you want to see something like that. Besides that, thank you for subscribing. Check out my software and course in the description. Follow me on Medium and take it easy.